because, okay. Hello everybody, welcome to the second workshop of the School of Data Journalism. We're very happy to have here Annabelle Church, who will take us through an introduction to mapping for journalists. Just a couple of words again about the School of Data Journalism. I'm sure you've heard it probably for the third time today, but this is an initiative of the Open Knowledge Foundation, the European Journalism Center, and the International Journalism Festival. We're very happy to be here for the third edition, 3 years in a row. Very exciting to be doing that. We'll be in total running 10 workshops, 4 panel discussions every morning. From 9 a.m. we are in Sala Raffaello in Hotel Brufani. Tomorrow we'll be talking, for example, about how to do data journalism for small newsrooms. And after that we continue with workshops. So as I said, this is the second workshop. Very happy to have Annabelle here. Feel free to tweet about what's happening now with the hashtag DDJSchool. Of course, with the hashtag of the festival as well, IJF14. We're taking notes. We're going to compile a small article with resources for each of the sessions. We'll send it via email to those of you who are already subscribed on our website, which is datajournalismschool.net. So if you haven't subscribed already, do so you can receive all these updates. And yeah, that's pretty much it. I'll let you get your hands dirty with maps and Annabelle.
Trouble with technology. Okay, I think I'm ready. Hello everybody. As Milena introduced me, my name's Annabelle Church. I'd like to thank the School of Data Journalism and the International Journalism Festival, Open Knowledge Foundation, School of Data, European Journalism Centre and Data-Driven Journalism for compiling all of this and allowing people like me to come and speak to you guys. And this is the hashtag, DDJSchool. So a little bit about me. I used to work at The Guardian as a developer. Sorry. Building tools and exploring solutions around storytelling and the future of digital journalism. I worked there for a few years, and last year I had the privilege of being an Open News Fellow embedded at Zeit Online in Berlin, also building tools, data visualizations, and anything I could get my hands on to aid and abet journalism. Can everyone hear me okay?
Excuse me, can you speak slower? A bit slower, can you?
I can definitely speak slower.
Thank you very much.
If I start speaking fast, just remind me. My New Zealand accent lends me to speaking very fast and very flat. So these are the Open News Fellows from last year. We were embedded in 8 different countries, helping 8 different news organisations try and understand what journalism is becoming. And it's kind of hard. So one of the ways in which we can engage, let's just turn off your notifications, Milena, which we are getting. Okay, one of the ways in which we do this, apart from evangelise and turn up to conferences, is that we try and teach people new things. So I'm here to teach you guys about mapping and the complexities around mapping. How many of you guys are actually trying to follow along with a computer? Okay, 1, 2. How many of you guys are journalists? Nearly everyone. Does anyone here have any coding experience? No? Okay. So I think what we'll do is we'll just try and keep to the basics. We'll cover off a lot of the theory around mapping do's and don'ts. Yeah, okay. So why do we use maps? We use it really to tell stories, to explore data, and to show things that maybe other forms of data exploration don't give us. So mapping is really good at geography. Some of you might be familiar with this map. It was created by John Snow in 1854, and it's a map about cholera. Nobody could decide where cholera came from. People thought it was bad air, maybe bad spirits, but nobody could really decide how cholera was spreading or through what mechanic. John Snow decided to go around and map all the incidences of cholera on this map. And as you can see, a lot of the incidences are around here. And there's a water pump there. And by using this map, they discovered that there was a water pump, and the correlation might have indicated that this water pump was causing the cholera. So what they did is the city just disabled the pump to see what would happen, and the cholera incidences went down. Now, it's not so clear, perhaps, that the map caused a complete understanding of the problem, but it definitely helped people understand what was going on now and after the fact, then and after the fact. There's one outlier in here. The monks near the pump did not get sick. They were drinking beer. Yeah. Okay. So, what should we map? Well, clearly we should just map everything that's geotagged, everything with data around geography. Everything, right? Well, it might be the case that we don't want to map everything. So I'm going to lead you through a few examples of what not to map and what to map. At the end of this, I'm going to put up, or maybe Melena's going to tweet it out later today, a link to all of the visuals that I show, all of the tools that I cover off, so that you don't feel like you have to keep up. You can go back and read the cheat sheet at the end. There's huge amounts of resources. So Matthew Erickson has written a great thing about what not to map. That will be up there. So let's go. So this visualization was done by The Guardian. Now, it's not a map, but it contains geographic data. And the best way to represent this story perhaps was to use a map, but it really wasn't. So you can see here that the data around, the most interesting data around the gay rights in the UK can be seen on this kind of pie-like graph. You can see that you're allowed same-sex marriage in the northeast, hospital visitations, all of these wonderful, wonderful things. Sorry, this is The Guardian writing about America. They have an office there too. Okay. And what's interesting about this is that even though it's geographic data, we're not displaying it as a map. So perhaps not all geographic data should be on a map. So this one here was done by Mother Jones. Now, it's to kind of highlight the fact that a map may not be the only attribute of your story. It is often an accessory. It is trying to... Yeah, so what I'm trying to say is the map is not the only thing. It is just one of the things that you have as a part of your story. So this is about legalizing marijuana. It's just a portion of the visualization. The visualization is much bigger, and it goes into depth about the legalities, the access, and the usage of marijuana. Cool. So Here's a map that maybe some of you guys are familiar with, US elections. This is done by the New York Times. Now, it's really good to see which, with the Democrats or the Republicans, won in what area. It's really easy. It's very easy to dive down. You might be interested only in your state, in your local area, but you can see at a glance what's going on. If you were to ask a different question, not who won or where, but factors into why, this isn't really data that you would be able to express with a map. So this is also done by the New York Times. And the question they wanted to ask was, what are the economic factors around who wins in which area? So you can display it on a map, but maybe it wouldn't give you a good understanding of where the key points are. The key points are these two dots here, where there's a marginal victory. All of these other places are far above the line, and you can see that they're clearly going to be Democrat. All of the dots on here are around your education level. Okay, so understanding maps. There's a lot of complexity around maps. People use a lot of jargon. There's geotagging, data, latitude, longitude, projections, map geometry, GeoJSON, KML, lots and lots and lots and lots of jargon. And I just want to talk to you about this in really, really simplistic terms. I don't want to scare anyone off, but maybe by the end of this, when you see this terminology out in the wild, it won't scare you as much, and you'll be able to put it in context, where it fits, what you can do with it, and what tools it's most relevant for. So maybe we need to explain a little bit about the world. So latitude and longitude. Some of you guys probably flew in here. I'll give you a good understanding of how big the world is, maybe about how round it is. It's not quite round. It's a bit like a bumpy sphere, a bit squashed. The most important thing about this little picture here is that latitude goes up and down between the North and South Pole, and longitude goes around, and that there are numbers associated with this. So if you're talking about the latitude, the equator is 0, and the North and South Poles are equally 90 and negative 90 degrees. The longitude, as you can see, all the lines that span out from the poles around the prime meridian, they also have figures minus 90 to 80 up here, you can see here. Now, I'm only scaring you with these numbers because primarily when you're working with maps, these are the things that you really, really care about. You don't have to know what they mean. You just need to know that every map is compiled with these latitude and longitude points. So, back when we sailed ships, we wrote latitude and longitude like this. We wrote it in degrees, minutes, and seconds. Now, unfortunately, while this is kind of human readable to us, sort of, or perhaps to the ship sailors, it's not very computer friendly. So in order to deal with computers, we need to work with decimals. So the same point, Perugia here, would be written like this, latitude and longitude. And if we're talking to a computer, it would be latitude, comma, longitude. Perhaps some programs take longitude, comma, latitude. So depending on which tool you use, you might want to think about whether they change that around. Nobody is consistent. As I said before, the world is sort of spherical-ish, and a bit bumpy. So we can't hope, perhaps, that when we flatten it out, that it will always be particularly realistic. So while maps are about the real world, they're not. Maps do lie. They distort certain areas of the planet, flat maps, and accentuate others. So continents and countries aren't always the right size, so bear that in mind if you're thinking about mapping data where the size of the country is some kind of indicator to your statistics. So in a perfect world, we'd be able to map things in a kind of rotating sphere, and we wouldn't have to think about flat maps. But unfortunately, we have to make the world flat again. Most of the time when we're doing journalism online, we have to think about the maps in terms of flattening it out and what bit we're trying to accentuate. So if you are working with this kind of map here, the Mercator map, you'll notice that like certain parts of it are incredibly distorted, and it horrifies most of the mapping people in the world. Okay, so as I said before, lots of terminology around this, but don't be too scared. Now I'm going to talk about map geometry. So once we've thought about our sphere and we've flattened it down, we want to talk about what it takes to create a map. Actually, I'll go back. These are called projections. It would take a little while to go into why you might use certain projections, under what conditions. Just know that there are a lot of them, and people often use them inaccurately. So if you're perusing a map, think about the kinds of distortions that it might be involved in that. Okay. So map geometry. I said that mostly before we were talking about latitude and longitude. Now when people talk about map geometry and latitude and longitude, what they really mean is I've got a map and I want to put some dots on it, and perhaps I want to outline a country which is a selection of dots with lines between them. So that's dots and lines, which are lists of dots. So maps are basically dots and lists of dots. And you can have these maps deal in a huge number of formats. You can have shape files. Shape files often come with a multitude of extensions with all sorts of different kinds of text in them. There's a geometry for all of the features, what order all of the shapes should be in, and the properties of each feature. So we've talked about lists of dots, your longitude and latitude of the points of your map. But what are features? Features, it could be like the name of your country, the kind of individual properties, the capital, whatever kind of informational data that you're trying to map. So you have these shape files. This is what a shape file looks like. You can see here there's a geometry. We're saying that there's a list of latitude and longitude lines that might make up a particular country, and then we call that country Chile, and we might have more data about it. If you're talking about a KML file, it looks a little scarier. It looks a little bit like HTML. If anyone's ever looked at the inside of a web page, lots of open brackets and closing brackets, KML is a bit like that. And you can see here, same lists of latitude and longitude points. There's two more formats, geo-JSON and topo-JSON, and they look a bit like this. This is what geo-JSON looks like. Topo-JSON is a bit more condensed. And JSON is another kind of describing format that you often see on the internet. You can see here that there are a bunch of coordinates. And the property name here. This is describing Colorado. So we have a map, and there are kinds of maps as well. So along with all of the formats that we might have, along with all the formats that you might have, you've got different kinds of mapping tools. Everyone here is familiar with Google Maps, right? Yeah, thought so. Okay, so Google Maps is a slippy map. What that means is that when you scroll around it, the map moves seamlessly under your cursor. You can zoom out and you can zoom in. And the reason why you can zoom out and zoom in and everything works so seamlessly is because in your browser's loading a bunch of square tiles behind that map. And it really only loads what you can see. So once you scroll, it loads in some more tiles. So if you're on a really slow internet connection, you can kind of see the tiles come in. And why this is important is that the different kinds of maps that you can use online have very different benefits. So the benefit of a Google map is that it can be resized to any size, so it's very responsive, which means it looks very nice on your phone, it looks very nice on your browser. And the other thing is that it loads on demand, so it's kind of bandwidth friendly. It's not really good for large sets of data or dynamic things. And it is this projection format that we talked about before, Web Mercato. So apart from the use with Google Maps, it's also used with Leaflet and a few other mapping tools. There are other kinds of mapping. These involve more complex pieces of technology that you guys There are other kinds of tools that involve much more technology, JavaScript and SVG and lots of other complicated acronyms. I don't necessarily expect journalists to wade into hardcore mapping with things like JavaScript, but definitely keep open mind about it. You can build some quite simple maps with just a little bit of JavaScript knowledge, and I'll show you a little bit of that later. So there's different map implementations, there's all of the things and the terminology around what kind of things that you need for maps, what are the features, what are the points that you want to place on it, what kind of shapes do you want to draw on your map. And now there's a decision around the kinds of story that you might want to tell with your map. So if you're talking about aggregate sets of data or very specific points of data, you need to make different decisions in your storytelling around what kind of maps to use. So we have a little wander into the kinds of maps. These maps also have big names, but don't worry about it. There'll be a list of all of the names of these kinds of maps after the session. So, there are choropleth maps. Oops, this is not a choropleth map. I'll have to get the link here. So this is a choropleth map. What it's showing is that, anyone can read German? Perhaps not. What it's showing is the gun ownership in different regions of Germany. So this mark here is 186 guns per 1,000 people. And this little bit here is 13 guns per 1,000 people. And what you might notice is that the densely populated areas, the largest cities, seem to have the lowest gun ownership. And some of these places down the south here, where a lot of hunting happens, they have a high gun ownership. And the relevance to the story is that they were trying to talk about gun deaths. And they really wanted to see what the correlation was between the people who died in 2003 and the gun ownership. Okay. Sorry, I seem to have old slides. Okay, so a choropleth map is a good way, the map that you saw before is a good way of just highlighting regions and quantities. It's really hard to compare between regions. So if your main point is to try and figure out whether a place has an abnormal number of gun deaths compared to another place related to the number of guns that they might own, a map like that might be really hard to read. Okay. Okay, so this is an incredibly distorted map. It's called a cartogram. And the way that this works is it takes a regular shape of the world and accentuates any proportion of the map with a lot of data in it. So the idea behind this map is to demonstrate how Guardian in 2012 expanded into America and was publishing a lot of news in America. So you can see here that this is the UK and this is the US. I lie. This is the US and this is the UK. And it's good in a way, but I think it's incredibly hard to read. So we've covered off a couple of don'ts. So this is a map produced by the New York Times. And what's really interesting about it is all I've done is put a lot of points on a map. It's called a point map. And you can see here the distribution of the population by race. So you can see which areas of New York have different racial distributions. Perhaps it's a poverty indicator as well. And this is really good in a way. This kind of map is quite good. You can zoom in on this. Sorry. Okay, another kind of map is a heat map. Just to give you a kind of overlay on top of a street map, perhaps, that gives you an idea of the, in this case, the homeless population. You can see that it's probably, it's very much centered in this area, and it fades out. You can use topographical lines as well to indicate this kind of map. Sometimes they're called isopleth maps. I want to walk you guys through a few more examples of these kinds of maps, but I need to pop out of my slides again. You can indicate on your map with symbols. You can indicate the quality of your data through highlighting things with choropleth maps, and you can also use symbolic indicators. So the really good thing about this is it's pretty. Perhaps a less useful thing about it is kind of hard to compare. But you can see here that this one in here, which is Slovenia, has an 85% percentage of population of people between 18 and 29 who are still living with their parents. And in here, Germany, 23%. So we know that the Germans don't like living with their parents as much. You don't always have to show the features of your map for it to be a map. This is a sort of interesting exploration of political data in Germany around the last elections. It was giving the difference of political voting in an area compared to the average in the country. So you can see up here that this pirate party has a really high proportional voting in Berlin compared and Kreuzberg compared to the national average. The chloropleth map. Okay, so all these maps describe your data in different kinds of ways. So maybe we have a quick look about why you might make these decisions. So one reason to use a dot map like this is that in this instance you can actually zoom down into the area that is most relevant to you. So perhaps you want to know what your the demographics of the area that you're in, and this is kind of a really good way of storytelling that data for you. Okay. So we have many different kinds of maps. We have different terminology for all of these kinds of things. And perhaps we want to have a little bit of a talk about the usability of maps. Sorry. So what's good about this? So when we're thinking about things like colour, what's good about this is that for anyone who's colourblind, actually the colours on these maps go from dark grey to light grey. If you're talking about presenting maps with maybe green and red, we know that for at least the colourblind, that's not such a great idea. If you're talking about accentuating your story, and when you're looking at data, you might want to think about whether you're working with aggregate data or sequential data. So if you've got sequential data, you might want to have. Let's see if I can find a map. Sorry. Okay. So how do we get our data? Well, it's everywhere. You can scrape it. Does anyone know what scraping is? We cover that on Saturday. But you can often download quite a lot of it. So the World Bank has a huge amount of data that you can download. I noticed that there was some nice data that you could download locally for Italy, which we'll go through in a minute. It comes in different formats, like CSV files, which are it's a complicated way of saying there's some information separated by commas. You can get it in spreadsheets, zip files, all of these other things. If you can't find your data, then you do perhaps have to resort to scraping. Scraping is just going out into the internet in the wild, looking at websites which have lots of data, but perhaps in a less accessible form in terms of mapping. So often with mapping, you want your data in a set in comma-separated values, perhaps in a spreadsheet if you're going to use Google Fusion tables. Having it in a web page isn't so useful. But often people have large sets of data out on the internet, just waiting for you to come along. but you can't download them. Or perhaps they're trapped in PDFs. In order to map that data, you have to kind of extract that. So if it's a website, you might have to scrape it. If it's a PDF, you might have to get the table data out. Sometimes you can compile your data. You can ask people to come along and provide you with some information. So the practicalities. There's difficulties around mapping. Often you have only country data, or you have latitude and longitude data, or you have some strange shapefile, and you're not entirely sure what to do with it. And there are a lot of tools out there which you can use to move between different kinds of data. So some of the things that you need to understand about mapping, perhaps, is that you often have to create a map from scratch just for yourself around the project that you're dealing with. Start from scratch. You can look at tutorials, find code online, or look at tutorials around Google Fusion tables, but start from scratch and then document the things that are hard for you, so that next time you can come back, try it again, and revise your documents. We've covered colour blindness a little bit. There are some great tools around colour blindness. I'll show you Colour Brewer in just a minute. Not every map has to be interactive. You can just use static maps as well, and use interaction when you think it's strictly necessary for your stories. And maps are not accurate. So if you want to tell a story with a map, make sure that you are aware of the map inaccuracies, and that you play with your data accordingly. Not every web browser supports all technologies, just bear that in mind. And learn when to make a map instead of a bar chart, or when to use a map instead of a sentence. Sometimes words and charts are really what you're looking for. So geography is hard, and data entry is also hard. So finding your data, cleaning your data, and using your data is hard. So I think we can have a little bit of a look around practical examples. So where do we get our data? So I got some data from here. The statistics, Italian statistics. And you can get this data in PDF, some tables. I'm going to download some zip files. So this is crime data. And we're going to have a bit of a look here and see what we've got. So it's kind of hard to read. So there's a selection of crime data in here. This particular set of data is by province. For the year 2010, the total number of crimes by province, and the number of people who they've caught reoffending. So that was really easy. Data, no problem, right? Download some data. But now, kind of, what do we do with it? Well, I think we should put it into a spreadsheet. If you don't have a spreadsheet program, you can, of course, use Google Spreadsheets. It's going to take a minute. Okay, can everyone read that? So here are some regions. So who here's Italian? Is this a province? City. And this is a region? Ah, okay. That's really cool. So once we have our data, there's a couple of things that we can do with this. Maybe we save it. Okay. So we have some data. I talked to you about KML files. I also have this KML file. And it just describes I don't know if you can see that very well. There are some very faint lines in here. So let's point this out again. This is a KML file. A KML file is describing the provinces of Italy. It's just a bunch of latitude and longitude lines. And I suspect that you can't see it from the back, but I'll point them out. This is a line that I can see with this map, describing this area. That's all the KML file does. Google is doing all of the rest here. It's placing a Google map behind the shape file so that you can just have a little bit of a scroll around. The shape file only describes Italy, so the rest of the world has no data describing provinces, because the file that I had here, that I just Googled for KML file for Italy, only describes Italy. So we've got some data, and we've got some shape. And maybe we need to think about what we want to describe here.
Are you guys following on your computers? Do you want to follow?
Oh.
Where did you find the caves and the file?
So often, people like the World Bank have different data sets and files. Lots of people have different file formats. So if I look here, yeah, I've closed the tab. So you can get KML files, topo.json files, geo-JSON files, shape files from all over the place. Often people create their own, so you can just Google for a KML file or a topo.json file. And sometimes you might want to switch between them. And there are a lot of converters. So let me just show you here. Here's a whole bunch of file converters from a link that I'm going to put up on your cheat sheet afterwards. So these convert from the different file formats. Because often an organization might only provide one kind of format. Maybe they're only used to using certain things. So if you're using Google Fusion tables for maps, you can use KML files. That's what Google understands. If you are going to construct a D3 map, does anyone know what D3 is? this is what I was talking about, SVG and JavaScript, and all these other kinds of tools outside of this kind of Google Map type map that you can create with code. They can use and consume different file formats. Okay. Does anyone have any additional questions? No? Okay. So let's have a look at what might be interesting about this data. You have your provinces and regions and macro areas. It might be that we really are only interested in maybe only in the provinces. So at least for this little exercise, I'm going to take out the higher regions. I assume that it drills down. Is my assumption correct? You have regions and provinces? Good.
No. Those are the macro areas.
These ones down here?
Yeah, under Sardinia.
Yeah, okay. What does that mean? Macro area?
South.
A bunch of regions put together.
Okay.
Yeah, south, northeast, northwest.
Yeah. I think we're going to just focus on provinces for our little quest in data, so that we can. Why is it not working?
But then this is not a very clean data set, though, no, combining all of these.
It's definitely not a clean data set. So one of the things that you'll find if you're ever working with data, you spend a lot more of your time working the data than working with the data. So once you've collected your data and you've kind of cleaned it up, maybe that is most of the legwork, right?
If you have questions at any point, please raise your hand so we can follow and understand.
I don't know what I'm doing. See, look, unable to delete. Okay.
I don't think it does multiple select.
No, it doesn't. Okay. Perhaps we'll just ignore it. Okay. In the aid of time. Okay. So it might be interesting for us to have a little bit of a sneak preview at what a map would look like if we were to create one in Google Fusion Tables. So you can see here that I uploaded the data into a spreadsheet. Now that's just the starting step. Now we have to get into a Fusion table. So if you don't have Google Fusion Tables as an option when you go to your Google Docs, you might have to connect the app. So you click on Connect and you find Google Fusion Table, and then you connect it, and you have then the ability to use it. So you'll get this this dialog. Given that I've already uploaded my spreadsheet so that I can clean the data nominally, you could just select it from your pool of spreadsheets. see if this works. So now I have a Google Fusion table.
Are you familiar with the difference between Google Spreadsheets and Google Fusion tables?
No. So the power of a Fusion table is that it can do a lot of filtering and a lot of manipulation of the data, and you can, inside the tool, map the data. There are a lot of tools associated with it, so it's much more around filtering and manipulation than a spreadsheet is, and about displaying the data. So if I click on the Map tab, you'll see here it's trying to geocode all of the data. Now, geocoding would give us latitude and longitude lines, points for all of the data. But because we talked about the kinds of mapping opportunities that we have. So if I've got a region and I put a point in that region to indicate something, it's probably a nominally on or off value, like a particular place. I might be trying to point out a particular crime occurred on what street, or I might be trying to point out where all of the cafes are. But if I have data that's split by region here, you can see that we don't have specific points about specific crime. We only have crimes for a geographic region. So it might be better to have a little bit of a look at a chloropleth map. So just to remind you about what a chloropleth map looks like. It looks like this. So you can see here that we're plotting some data by region. We're saying that the aggregate data for that counts towards that region. We don't have any idea where any specific point is, and we can only draw conclusions based on kind of that regional information. And you can see here that there's this sliding scale, 0 to 175 and above guns per 1,000 people, each block indicating a number. So we don't want to put points on this map. We want to think about it in terms of geographic areas. So in order to do that, we have to import the KML. So I think, I don't know if this is... Yeah. Unfortunately, I only have a KMZ file, which is a zipped form of KML, and I can't upload that to Google Fusion. So what I'm going to show you is different data, unfortunately. I was hoping to do Italy local data. Okay. So this is violence map data for the world. It's governed here by broken down here by country, And we have some extra data here, the age group that it's related to, the percentage of incidences so 1 out of 3.4 instances with violence against women in this year. Unfortunately, this data has some blanks in it, so we'll notice that when we map it. So in order to work with the KML file, you have to import it also into So I'm importing this KML data into Google Fusion Tables so we can have a wee look at it. So this is the world country boundaries rather than the local Italy region boundaries. And we'll be able to have a wee look at this. So this is KML here. There are some coordinates. The coordinates are indicating the bounding box. And we have a key here, the name of the country here, Andorra. So you have some describing stuff for the region and the name of the region. So we want to merge it in with the data that we want to map. Sorry, I'll just try and find that for you. So 2 fusion tables, and we're going to merge them together. Now, the only thing really to remember when you're merging data is to make sure that the thing that you're merging with in both tables is the same. So you can see here that this lists the country, and this lists some stuff. Now, we want to make sure that that is the right one. Now, you can see here that there are 2 name things. The first name thing is also looks like some more stuff with some angular brackets, and the second name thing looks like actual country names. So we can merge that now. And you can see here that the KML sits in here and the country data is there. So when I click on map and zoom in, we get a lot of red. So you can see here that some countries are blank and a lot of them are red. Red is not very descriptive. So we know that from our data, there was a range of data. And we know that on our map, we can only see one. So it might be that our regions, the granularity by which we define the colour in each region is not big enough for the data that we have. So we have the ability to define out what our colour range is going to be. And we can choose any one of these to govern, to map. So what do we want to map? We have this percentage 2, which is really badly named, I've decided. Perhaps I can spell. Wonder if it will upload. Doesn't update. Okay, I'll have to come back to that. So we have this range of 0 to 0.6, which is 0 to 60%. And our numbers here are all really, the bucket is really large. The bucket covers nearly all of the range of the data that we have. So this is actually our percentage, isn't it? Ratio and percent. Okay. So we want to use this range. We'll only have 2 buckets. So maybe a better idea is to bucket our information in much more granular portions and use that range. So you can see here that all I did was find the column by which we want to bucket. Bucketing is just a way of saying, I want this colour to be for this data range, this colour for that data range. And then I've used that bucket range. Okay. Actually, wrong one. Sorry, I'll just do this in the right place. Okay. Now we should be able to see. Okay, unfortunately, our data set is incomplete. So wherever you see this red, we have no data. Now, in an ideal world, we would make sure that we had data for all of the places that we wanted, or we made it so that it was not such an alarming colour as red. So colour theory. So we've noticed here that we have this huge range of colours. And our eye can't decide which is the highest colour and which is the lowest colour, because these colours have no range to our eyes. So we need to think about it in terms of either a singular colour or a multi-colour scheme that can indicate low to high. So colour brewer is a really good tool for that. And it suggests specific colours here. So you can select any colour scheme that you want, and it has a nice example. So if we take our lead from Colour Brewer, it might be nice to change all of these. Now I could go through and put in the nice Colour Brewer numbers, which are what these are, the hexadecimal numbers for the colours. By selecting them out of here, you can see the same number here. This is just a way of indicating which colour you're talking about. Or I can just mark them by hand quickly. And we're running out of colours. And I'm not going to choose red actually, because unfortunately our blank cells are coming up as red, so that would make them really hard to see. So we save that. And we can see here that Cameroon here has a 50% violence rate, and Nigeria has a 15%. So on the understanding that we don't have holes in our data and that we can get all of our shapes on the map, you might want to embed that. And you can do that with Google Maps. You can share it. You can embed it. Share it with your friends. And it's resizable. So colour brewer and mapping. Does anyone have any questions so far? Before we have a wee look at some other kinds of mapping tools that are fun. Okay, so maybe I'll just run through the available tools and their use cases. So we have Data Wrapper, which does charts and maps, and I believe that Simon Rogers is going to go over that tomorrow. Yeah. Along with CartoDB. So we don't have to go into that too much. There's Leaflet, which requires some understanding of some code. So this is a choropleth map as well. So there are some tools that you can use to embed maps, like Data Wrapper and Google Fusion Tables, CartoDB. And there are maps requiring you to write a little bit of code, or a lot of code in the case of D3. So if we have a little bit of a look at this, what does the code mean? So this, actually we can view this, has some code. So not too scary, but I'm going to run you through some basics so that at the very least you can understand what the components are. You don't have to create your own, but then you can get an idea of the underlying technologies. So you can see here there's some HTML. Leaflet has some JavaScript. And you can see here that the JSON file just contains some points and coordinates for each state. So Leaflet is just some JavaScript, a simple set of HTML that you have on the page, and these coordinates on the page to create this kind of map. So very small number of technologies. And it runs off GeoJSON, as I said earlier. So you've got lots of tool sets available. You've got lots of language around what is a point made of and all of the data formats. You've got different kinds of maps, like choropleth maps and point maps. You have this idea of projections that might distort maps. You have user interface design considerations like color and the use case, like whether you want to browse it on your mobile phone or on your web browser on your computer. And everyone has to come to these conclusions for each story that they want to tell individually. So I just wanted to say thanks very much. Does anyone have any questions? No? I'm going to put a cheat sheet out of all of the tools and any of the terminology so that you guys can have a bit of a read after if you like.
Thanks so much, Annabelle. So, I don't know if you can hear me. Yes. So just wanted to say that even if it sounds maybe quite complicated, it's really not that intimidating. So it's just try out some of these tools. You'll see what a satisfaction you'll have when you put the first dots on the map. The Fusion table is especially easy because it does all the geocoding for you. So you have the name of the city, and you press a button, give me a map, and the Fusion table will know that that's a city and will know how to look for the latitude and longitude and will know how to put the dot on the map, even if you didn't give it the coordinates. So it's really a matter of practicing, and I'd really encourage you to check the cheat sheet as soon as it's ready. We'll send you all the documentation. We have lots of notes from this session. We'll put it up in an article. And just practice. And don't let yourself intimidated by bits of code, by different formats like XML or GeoJSON or KML or whatever. There are so many data formats that it's really hard to... They all have brackets that are, if it's not CSV and easy to read, they have some brackets and weird coding pieces. And don't get intimidated by that. It's not as hard as it seems. So thanks a lot, Annabelle. We'll take a 10 minutes break, and Mariana will come for an interactive storytelling session. She's an interactive designer. She worked with The Guardian. She did a fellowship with Night Open News. And she's running this program called Chicas Poderosas in Latin America, and she will teach us how to do scripting and how we can build a bit of life to our graphics. So stay if you like, or hopefully you will, or go to another session. And yeah, see you in 10 minutes. Thanks a lot.